So we will be talking about circular motion, and in circular motion, our main, of course, circular motion is okay. First of all, um, to have a difference or to know the difference between our today's topic and regular motion, which is of course a linear motion. Okay. Now, so when we talk about linear motion, uh, we mostly talk about one dimension, which is x-axis. Okay, so in this we have a straight line. We're in a straight motion. There's no change in direction. So in this motion, this is the velocity, and this arrow on top of velocity means direction. So velocity is the it has because we know that velocity has direction and magnitude both. So this arrow represents my velocity, plus we know that that means if it has a velocity, it must have acceleration as well. Acceleration on the condition that it has a changing velocity. But if velocity is constant, then acceleration is 0. Okay. Now then, um, so to see the forward force, what the forward force is, we would say F equal ma, mass of the truck or car times its acceleration, and this is friction as well. Weight is also there. Weight should be down here, and so on. So coming to our topic, circular motion. The main thing in circular motion is that now whatever scenario we will have, there will be a circle involved in this. Okay, so if this is an object and it's moving in a circle, so when it's moving, this is its velocity, and this over here will be its uh, radius. This r is showing the radius from the center, or well, radius is what uh, any point from the edges of the circle to the center point is radius. So, and this over here we will have something over here we have is acceleration. Okay, and this acceleration is actually the product of this velocity squared over r. Acceleration c means acceleration in circular motion, and when we talk about circular motion, there's this one important force which is always mentioned, which is known as centrifugal force. Centrifugal force. Fugal. I may have spelled fugal incorrectly, or let me say fugal force. Okay, I think ph. Whatever. Our main thing is concept. So this centrifugal force is a force. Centrifugal force, okay, is a force which only occurs, or um, which is only applied when the object has a circular motion, when it is moving in a repeated repeated shape, meaning this is a circular motion, If it goes around the circle, it will return back to the same point. It's a circle. That's a circular motion. Even this could be a circular motion as well, because even though it's not a perfect circle, but we still it's in a circular motion. This over here, but again the shapes are, even though it's a circle, but the only thing is that the perfection of the circle reduces, but it doesn't like it doesn't make it not a circular motion. Still we have a circular motion, still we have a circular motion, still we have a circular motion. Okay, now next is that we will talk about time and frequency. Time is actually the total time taken to do a lap over the number of cycles. Okay, so that means total time to do the number of cycles over the cycle will give you um, will give you second per cycle, or how many seconds were taken per cycle. So but basically time on we don't know, we don't actually call it time. This is actually called known as period. Okay, period is nothing but the number of waves or number of cycles passing through a certain point in how many seconds. It's up there. How many seconds are taken for a cycle to happen. Frequency and time are related to each other, and frequency is nothing but the number of waves passing through a certain point in certain time, which is cycle over time. It's a reciprocal of t, because t is also written as the period is also inversely proportional to frequency. So now this could be written as 1 over f, 1 over t, sorry, 1 over t. Now here, um, the main what we want to talk about is uh, in circular motion. In circular motion, when we have uh, the radius, this radius r, and the t, time taken for the whole lap, we could use equation v equals 2 pi r over um, t. And you might have noticed this 2 pi r is nothing but the circumference of a circle. So, and this equation over here is very famous in astrophysics, because v equals 2 pi r over t is used to know the speed of the planet, to know the speed of the planets. Okay, let's suppose if this is our earth. Okay, if this is our earth and um, it's revolving around the orbit, and let's suppose it takes 24 hours to do the full orbit. And when it does full orbit, and we have the radius of the earth uh, from its let's suppose of course sun is orbiting around the sun, so this is radius. So our velocity will be 2 pi r over 24. This will give us kilometer, or depends on the value of r, but we have kilometer or meter. We have our values kilometer per hour, but mostly this unit is used, or meter per second, or we could say meter per second in this way as well. These are same. We get these are same. It's just the difference of units is the, like the way we add units is different. So in this over here, this equation is mostly for the astrophysics. We use V equals 2 pi r over t. Now the centrifugal force. When we talk about the centrifugal force is actually um, has, let's suppose if we have many points, okay, we have a circle, and in the circle we have three compartments: A, B, C, and D. So centrifugal force, the equation for centrifugal force is pi r, or it's actually F equals ma, and this A is actually the centrifugal the acceleration. This one, where is it? Centrifugal acceleration. So what this equation, then we expand this equation and we get mv square over r. Okay, this is our centrifugal force. Now when we talk about the centrifugal force in these two compartments, these two regions are C and A, we only write F equals to mv square over r. Okay, so and v square over r plus minus, because velocity could change in terms of direction. Velocity can change in, can become negative or positive, and but I don't think so this is necessary for now. Okay, yeah. So but when we talk about the centrifugal force in the minimum, or minimum height, or below and above, okay, when you talk about them in above and below, we add one more force which is known as weight. Okay, weight plus the centrifugal force. Now how will I write it? F net, now F, of course F net is what we will call it, is now mg plus uh, mv square over r. This is one. Second one is F net equals to mg minus mv square over r. Now you might be wondering why there's a difference of sign. Why? Right? Now when we talk about centrifugal force in the bottom part, isn't the gravity applying here, the gravity the most, or we're going, we're in the direction of gravity? But when we talk about at the top, we're actually we're talking about opposing gravity, oppose with. Okay, that's why this negative one goes to the top and this positive one goes to the bottom. Now when we will look at this equation, when we look at this equation deeply, not deeply, the specific part I want to show you, mg minus v square m v square over r. Now look at this part carefully, this part, or to be precise, this part. When we find this part more than when uh, mv square over r is more than mg, and we get a negative value, then that means that the object is not in contact with the with the ground. Okay, that means, let's suppose if this is the equation at this point, if m if this is over here and we result in a negative value, okay, that means this object over here is right now in the air. This is what the equation says. And here, this is where equation, what's the equation actually? uh mg minus mv square over r. This is where it's used. Plus, when we talk about the object from the on this curve, here we will use mg plus mv square over r. Okay, and this is where we use. This is min and this is max. As at the bottom, g is the strongest. And when this g is at this curve, the acceleration which it has is outwards. Okay, and yeah, so okay. One more thing, when we talk about, I should have said this in the starting of the video. When we talk about the velocity in particular in circular motion, even though velocity's magnitude remains the same, or it could remain the same, the direction is always changing. There is always change of direction. How? Maybe at this point it's this direction, at this point it's this direction, at this point it's this direction, at this point it's this direction. So every time direction is changing. So according to the directions, we say that the velocity keeps on changing, or we can say velocity is not constant in terms of direction, because we here as it's a vector quantity, we have to take the direction into account. And so let's suppose if we have an equation, we are given this is equal to what this equation is over r, and f equal ma. These are the two equations we are provided. And majestically, see, let's suppose if we combine these equations. By the way, one more thing, uh, we over here when we wrote this equation, where is it? This equation over here. Did you notice something? That AC is equals to V square over R, and V is equals to 2 pi R over T. What do you notice? This V and this V, they're common. So we could make the equation, expand this equation again to get 2 pi R over T over, this is square, over R. And which in turn gives us, yeah, that's how it, just remember this is how the equation will be, and then you can simplify to get the simplest form, simplified version as your choice, if want, okay. Now uh now then, and yeah, other than this, everything is yeah, that's it. Thank you.